Hello dear students, how are you? Wish you are all safe and healthy, and welcome again to our online session. Today inshallah we're gonna start section number 2. Our lesson actually is very important, and here we will see how we will apply what we learned about assigning the oxidation number of atoms in compounds. So today's lesson will be about balancing redox equation. So let us start, guys. Objectives, inshallah. By the end of this lesson we will be able to explain what must be conserved in redox equations, and we'll be able, inshallah, to balance redox equations by using the half reaction method. So the half reaction method for balancing redox equations consists of 7 steps. Step number 1, guys, we need to write the formula equation if it is not given in the problem. If it is given in the problem, it should be written in the ionic form. So we should write the ionic, the complete ionic equation, as we have learned before. Number 2, we'll assign the oxidation number for each atom or ion inside the compounds that we have in our equation. And after that, we'll deal with substances containing only elements that do not change oxidation state. So after we assign the oxidation on both sides of the equation, we will ignore all the substances that didn't change their oxidation state, and we will just keep the substances that changed their oxidation state. Step number 3, we write the half reaction for oxidation, and we write the half reaction for reduction separately. And for each of these reaction, we need to balance the atoms as well as the charge. So we balance the atoms and we balance the charge for the half reaction for oxidation, and we'll do the same for a half reaction of reduction. So step number 5, conserve charge by adjusting the coefficients in front of the electrons so that the number lost in oxidation equals the number gained in reduction. So this step is very important, guys. Why? Because later we need to combine the half reactions, the half reaction for oxidation and the half reaction for reduction, and we can't do that without having the same charge for both of these reactions. So here we should make sure that the number of electrons gained or lost for both of the reaction is equal to each other, and we'll see, inshallah, how can we do it when we start solving our first problem. So for step number 5, inshallah, it is clear. After that, as I said, we will combine the half reactions and cancel out anything common to both sides of the equation. So we need to cancel out the spectator's ion. The final step, step number 7, combine ions to form the compounds shown in the original formula equation, and then we need to check to ensure that all other ions balance. So this is what we call the half reaction method for balancing redox reaction. And here again, guys, we have the same steps in a different way. And number 1, identify reactants and products. We write the unbalanced equation. So of course it's unbalanced, of course we need to balance it, right? So write the unbalanced equation in ionic form, excluding any spectator ions, and then we'll assign the oxidation numbers. Then we'll identify the atoms that change their oxidation numbers. But for the atoms that didn't change their oxidation number, we will cancel them, as we said. So ignore all species whose atoms do not change their oxidation number. So step number 2, write and balance the half reactions. Separate the equation into its 2 half reactions. For each half reaction, do the following. So A, balance atoms other than hydrogen and oxygen. We will balance all atoms except for hydrogen and oxygen, because we will balance them in a different way, as we will see later. B, balance oxygen atoms by adding water molecules as needed. So how we balance the oxygen atom? By adding water molecules as needed. And we will balance hydrogen atom by adding what? By adding one hydronium ion for each hydrogen atom needed. And this is very important, guys. Point B and C, please be careful of these points. So again, how can we balance oxygen? We balance oxygen atoms by adding water molecules as needed, and we balance hydrogen atoms by adding one hydronium ion for each hydrogen atom needed, and then by adding the same number of water molecules to the other side of the equation. Inshallah, we'll see how we'll do that in our problem. Point D, we'll balance the overall charge by adding electrons as needed, as we said, because this step is very important in order to combine both of the reactions together. Okay, so step number 3, make the electrons equal and combine half reactions. So here we multiply each half reaction by an appropriate number so that both half reactions have the same number of electrons. Now the electrons lost equal to the electrons gained, so charge is conserved. So we need to make sure that atoms are conserved and charge is conserved. So the last step, we combine the half reactions and cancel anything that is common to both sides of the equation, as we said, and then when we verify our result, how? By double check that all atoms and charge are balanced. Again, we need to make sure that the atoms are balanced and the charge are balanced. We need to make sure that atoms and charge are conserved. Okay, so now let us start our first problem. So here we have our sample problem. Sample problem A. A deep purple solution of potassium permanganate is titrated with a colorless solution of iron sulfate or ferrous sulfate and sulfuric acid. The products are iron 3 sulfate or ferric sulfate and manganese sulfate, potassium sulfate, and water, all of which are colorless. The question is, write the balanced equation for this reaction. So again, we follow our plan. Step number 1, write the formula equation. If it is not given in the problem, then write the ionic equation. So here we have our formula equation: permanganate or potassium permanganate reacting with ferrous sulfate and sulfuric acid to give us these 4 molecules as product. Okay, so we have the formula equation. The first step is to convert this into an ionic equation. As we have learned before, we will just separate the positively charged ions and the negatively charged ions for each of these compounds. Okay, so we can get this ionic equation. Step number 2, assign oxidation numbers to each element and ion, and then delete substances containing an element that doesn't change oxidation state, as we said. So here the oxidation number of potassium is positive 1. For the manganese, guys, the same way that we did it before in our previous lesson, oxygen, as we know, is negative 2, and the rule says that if we need to calculate the or to assign the oxidation number for an atom in an ionic compound, here we have an ionic compound, not a neutral compound, the sum of all the oxidation numbers should be equal to what? To the sign of this ion. So the sign here is -1. So we will find out the oxidation number of manganese as the following way: 4 multiplied by -2, which is the oxidation number of oxygen, plus X, which is the oxidation number of manganese, should be equal to -1. So 4 multiplied by -2 is -8. -8 plus x should be equal to -1. Then you do the calculation, and the oxidation number of manganese will be +7. So super, right? Then for iron, the oxidation number is +2, as you can see. For this, and guys, again the same rule. I think it was rule number 8 or 9. Again, here we have an ionic compound, and the charge here is -2. So the sum of all the oxidation number of the atoms here should be equal to -2. So 4 multiplied by the oxidation number of oxygen, which is -2, equal to -8. -8 plus x should be equal to -2, and that's why the oxidation number of sulfur will be 8 minus 6, or 8 subtract 6, 2, and then the oxidation number will be +6. Okay. For hydrogen, as we know, the oxidation number is +1, and again the same oxidation number for the oxygen and sulfur. -2 for oxygen, and for the sulfur is, as we calculated, +6. Iron here has a different oxidation number, as you can see, is +3. Again, we have the same anion here. The oxidation number of sulfur is +6, as we calculated, and for oxygen is -2. For manganese is +2, and as we know, manganese is in group number 2. Again, we have the same oxidation number here for this anion. For potassium is +1, the same oxidation number here, and for water molecule, for the oxygen is -2, and for hydrogen is +1. So here we just calculated or find out the oxidation number of manganese and for the sulfur, and we use the same way as we said. The rule says that the sum of all the oxidation number in an ionic compound should be equal to the sign of this anion. Okay. So now, after we assign the oxidation number to each element and ion in this equation, what we will do next, we need to recognize any atom or any ion that didn't change its oxidation number will be cancelled out. So for potassium, for example, let's say it was +1, this side of the reaction, and here the other side of the reaction is +1. So we need to cancel the potassium from our equation. What about the second compound here? We have the permanganate ion. Okay, so for manganese, for example, here it was +7, and then it decreased into +2. So we need to keep these two ions in our equation. So this ion is on the left side, so it will be here on the reaction, or on the reactants side, and the manganese will go to the products side of the equation. Okay, and you will complete the same way for the other compounds, guys. So only ions or molecules whose oxidation numbers change are retained, which is the permanganate ion, the ferrous iron, the ferric iron, and the manganese as a product. Okay, so now step number 3, write the half reaction for oxidation. The iron shows the increase in oxidation number, therefore is oxidase. Okay, so here again let's go back to our equation. As we can see here, the iron, the oxidation number of iron changed from +2 into +3, so the oxidation number increased, which means that the iron is oxidized. Okay, so now here we have our half reaction for oxidation, and then we need to balance the mass, and we can see that the mass is already balanced, so we don't need to change anything here. Okay, so now we need to balance the charge. As I said, we balance the mass and we balance the charge for each of the reaction. Okay, so to balance the charge, guys, as you can see here, what we'll do, charge here is positive 2 and the charge here is positive 3, so we need to decrease the charge on this side by adding 1 electron. This way both of the charges will be equal. So now we need to write the half reaction for reduction. Manganese here is reduced. Why? Because as we can see, the oxidation number of manganese decreased. Okay, so we write the half reaction for reduction this way, and then we need to balance the mass and we need to balance the charge. Okay, for the mass, guys, as we can see here, is unbalanced, so we need to balance the mass in this equation. So guys, as we said, here for the permanganate we have here 4 oxygen atoms, so we need to add 4 oxygen atoms on the other side. How, guys? Remember the rule, we say to balance the oxygen atom we need to add water molecule as required. So here we need to add 4 water molecules so we can get 4 oxygen atom. Okay, and now we got hydrogen, guys, on this side. So to balance the hydrogen atom, we say that we need to add hydronium ion to our equation as needed. So here on the other side we will add 8 hydrogen cation or 8 protons. So this way we will have our equation balanced for oxygen on this side and for oxygen atoms on the other side. And here we have 8 hydrogen atoms, and on the other side we have 8 hydrogen atoms as well. So after balancing the mass, we need to balance the charge. As you can see here, the charge on this side is positive 7, on the other side is positive 2, so we need to reduce or decrease the charge here. How? By adding 5 electrons. So we add 5 electrons on this side so we can balance the charge. So step number 5, we need to adjust the coefficients to conserve charge. How, guys? By, as we said, we will multiply both of the reaction with an appropriate coefficient. So in the first reaction, which is the oxidation reaction, we lost 1 electron, so here we will multiply it by 5. And for the reduction reaction, we gained, or this reaction gained 5 electrons, so we multiply it by 1, and this way we'll have equal number of lost and gained electrons. So here 5 electrons lost in oxidation and 5 electrons gained in reduction. Step number 6, combine the half reactions and cancel out the spectator ions. So now, guys, step number 7, combine ions to form compounds from the original equation. So this is our final step. So here, after we combine both of the reaction together, we will get this reaction, and as we said, we will cancel out the similar atoms or ions. And then here, guys, you can notice that we multiplied the whole equation by 2. It's just to balance the equation, and you can do it later after you write the final formula equation. So now how we should write this equation, guys? Remember the problem, the ferrous ion appeared as ferrous sulfate, and the permanganate ion appeared as potassium permanganate, and the hydrogen appeared as sulfuric acid, and so on, guys. You will refer to the first slide that discussed the problem here, guys, and you need just to write the ions as they appeared in the original equation. Okay, guys, so that's all for today. Thank you, and see you inshallah tomorrow.